have an absolute value that is greater than 0. Okay, have an absolute value that is greater, okay, than 1. Okay? Again, so let me just summarize that. Okay, so y, this is a first order autoregressive process. Okay? So y is stationary. Okay? If and only if the roots, okay, so let's say the roots of the Lac polynomial have an absolute value which is greater than 1. So let's say if you have that, this is equal to 0, then you would conclude basically that the absolute value here of that expression is going to be greater than 1. Okay? So this is a statement that you're supposed to have. And that is a condition that can be extended for not just, you know, this is not only true for first order autoregressive processes, but also for higher order autoregressive processes as well. Okay, so the roots, if the roots of the Lac polynomials have an absolute value, which all of them, not just one, all of them, okay, which are greater than 1, sorry. So if the absolute value of all roots of the Lac polynomial is greater than 0, then the process is going to be stationary. Okay? Is that clear here from this example? I'm sorry guys. My voice is kind of disappearing now. Okay? Do you understand it? Okay? So again, this was the case here. Y is stationary if the absolute value of this coefficient is less than 1. Okay? And that is equivalent to the fact that the roots of the Lac polynomial have an absolute value which is greater than 1. Okay? So if the roots of the Lac polynomial have an absolute value which is greater than 1, then the process is also stationary. And that is also a result which can be extended to, let's say, to other processes as well. Okay? All right?
You said again the conditions for higher orders of autoregressive.
That is also true. Okay? Not just, I mean, we were looking at, this is what I'm going to extend it later. Okay, so here, of course, this is the general case, and that will be applied for higher order autoregressive models as well. Okay?
If all the roots
All.
of the Lac polynomial
Yes.
is absolutely greater than 1.
Yes, yes. The absolute values. The absolute values are greater than 1. Okay? Alright? So, and that is also true for higher order autoregressive processes as well. Okay? So this can be extended for higher order autoregressive processes. Okay, so basically, I mean, this is not intuitive why it is, but that's basically the mechanism that applies here. Okay, so let's say, for instance, if, and that is also true, and we're going to extend it here. So if, let's say, y is a higher order autoregressive process, and the process is stationary. Okay, if and only if, okay, and then I'm going to show you an example. If and only if the roots of the Lac polynomial have an absolute value which is greater than 0. Okay, so this means that if let's say capital A is a Lac polynomial, okay, has a root that is at point z that is equal to 0. That this implies, that this shall imply that the absolute value of that would be greater than 1. Okay. So if there is a root, okay, then this should imply that the absolute value of this should be greater than 1. Okay? Let me just give you an example. Okay? So basically, I mean, you don't see this. Okay? Maybe we're talking about. So let me just give you a higher order autoregressive model. Okay? And this is also part of the exercise 3.4. Okay, so this is going to be an example. Okay, this is example 3.4. Okay, so what I have here is this. Okay, so let me just give you a process. So here you have yt, equals, let's say, whatever. Okay, so let's say you have a constant plus 0.3 times yt minus 1, okay, plus 0.1 times yt minus 2, okay, plus the white noise. So here you have basically a second order autoregressive model, okay? Okay, so this process is a second order autoregressive process, okay? So now we want to figure out whether or not this process is stationary, okay? So what we need to do here for that is we're gonna need to look at the roots of the lag polynomial of that. Now first off, we need to establish a lag polynomial. Now how does it look like? Okay, so basically this is what it is. So here you have the lag polynomial times the process, okay, shall be equal to, and then you have the constant plus the white noise. That is always the case. So this is a representation that is not only true for first order autoregressive models, but also for higher order autoregressive models as well. Okay, so you probably have seen it, you're probably all familiar with that. Okay, so now how does the lag polynomial look like here in this case? Of course, if you want to rearrange that, then you need to have, I mean, this is what you have here. So you need to have 1 minus 0.3 times L, and then this is the first leg here, okay? So that's why you have negative, so here you have -1 here, so that's why you have an exponent 1. And then you have 0.1, okay, times L to the power of 2, okay? So because you have the second leg here at that point. Okay, so this is how the lag polynomial look like. Okay? So far so good? Is it okay? Now let's calculate the roots of the lag polynomial. Okay, so let's say that a of z is equal to 0. So then what? So then what you have is 1 minus 0.3 times z minus 0.1 times z squared is equal to 0. Okay? Now this is just a simple quadratic equation, guys. Okay? Right? So we're gonna look at the roots here of the function. Okay, so now how do we do this? Of course, we can multiply by 10 if you like. Okay, so you don't have to, but this is quite okay. So or by -10, it's even better. Okay, so by -10. So then you're gonna have z squared, right? So then plus 3 times z, okay, minus 10 is equal to 0. Okay, so this is a quadratic equation then. Okay, and here you have that z 1 and 2 equals 2. Okay, so this is p and this is q here, so you have negative p half. Okay, so this is going to be negative 3 over 2, right? Plus minus 3 over 2 squared equals 9 over 4. Okay, minus 10. Okay, so minus -10 equals plus 10. All right, so plus 10 equals 40 over 4. Okay, so 9 over 4 plus 40 over 4 equals 49 over 4, and the square root of 49 over 4 equals obviously 7 over 2. So you have -3 over 2 plus minus 7 over 2. Okay, now the first root is going to be what? So you have -3 over 2 plus 7 over 2 equals 4 over 2. Okay, 4 over 2, which is equal to 2, if I'm not mistaken. Okay, right? And what about the second root? The second root is equal to -3 over 2 minus 7 over 2. -3 minus 7 equals -10. -10 over 2 equals -5. Okay? Now guys, here in both cases, you have that the absolute value of the first root is equal to 2, which is greater than 1. And the absolute value of the second root is equal to 5, which is also greater than 1. So the roots of the lag polynomial are greater than, or the absolute value of the roots of the lag polynomial are all greater than 1. Now, since that's the case, right, the process is what? The process is stationary. That's it. Okay? That's how you examine it. Okay, so this is going to be, okay, so y is stationary. Okay? So based on the characteristics of the Lac polynomial, I can identify whether or not the process is stationary. And if that is always true, no matter which order you have. I mean, for the first order, it's quite intuitive. Okay, so because if the absolute value of the slope is less than 1, then it means that the roots of the Lac polynomials have an absolute value which is always greater than 1. Okay, so if the constant has a value which is less than 1, then the root, there is just one root because it's a straight line, then the root of the Lac polynomial will have an absolute value which is greater than 1. Okay, so the process is stationary if and only if the root of the Lac polynomial has an absolute value which is greater than 1. Now this property regarding the roots of the Lac polynomial can be extended for higher order autoregressive processes as well. So if you have, let's say, a second order autoregressive process, all you need to look at, okay, whether or not you want to examine whether or not this is stationary, you only need to look at whether or not the roots of the Lac polynomials are greater than 0. Okay? Okay? Right? Okay? Good. Okay? Is this something that you have understood? Okay? So, I mean, this is going to be an easy task, let's say, for the exam, for me. Okay? So what I'm going to give you, I'm going to give you a process. Okay? And then you calculate the roots of the Lac polynomial and you check whether or not the process is stationary by calculating the roots of the Lac polynomial. Of course, I'm not going to say, okay, that you should calculate the roots of the Lac polynomial. But I'm going to give you like a process and then you have to tell me whether or not the process is stationary. Okay? Okay? So I think, right, that should be fine. Okay, so, yeah, this is this is a typical example for the exam. Okay, that's easy, I think, right? So maybe you have to solve a quadratic equation, maybe a cubic one, I'm not sure. Okay, maybe any of those. Okay? Right? That's going to be a gift for me. Okay? All right, but provided that you understand this. Okay? Do you get the point? Okay? I apologize here for these technical difficulties. I hope it doesn't happen to me again. Okay? But basically, it's not my fault. So if you figure out Windows 10 how to shut down these stupid updates, I'm not talking about the updates of the, so for let's say for safety reasons, but the updated version here for certain, this editor here, because the updated version doesn't work. Okay, so that's the point. Okay, guys, now I think I'm going to stop here, and then we're going to talk next time. Okay, please do not forget your assignments. All right? Okay, excellent.